Hello everyone, I'm Bradley Sward and this is my alternate solution to day 12, part 2 of the Advent of Code 2024. The problem is called garden groups. I did this again in Python and now I have a second way of solving the problem. So again, just to remember, we have groups of gardens and we need to figure out, at least for part 2 here, we need to figure out the area of each particular plot, and we also need to figure out how many sides make up that arbitrary shape. So in this case, A is a rectangular shape. This is a square shape for B. C looks like a Tetris piece. D is just a dot. And E is a 3 by 1 grid. So I mean, it's arbitrary. It could be, and they show you all sorts of crazy nonsenses as to what it could be for each of the individual parts of the problem. But let's take a look at how we're going to solve this using the alternate method. So my first solution used, let me find it here, my first solution used the methodology from the previous video where I figured out, and someone didn't like this video, so if could you mind commenting of why you didn't like my video? The code wasn't the greatest, I get that, but it did get the problem solved. And in my defense here also, this solution will get you both part 1 and part 2 in one pass. So it's one of those things where, and then the alternate method I'm going to show you today will not get you part 1, it will only get you part 2. But just to say, so what did I do in this previous part? I generated a map of characters, like of a 2D array. I probably didn't need to go that complicated, but I did. But then what I did was just get me any element that's left in this thing, and then get me all of the things connected. So get me the grouping of, get me the specific plant type for the garden, get me all the items in there, and then I go through here and I figure out on a 1 by 1 basis. I try to figure out where the fence lines should be, and then I match them all up and I try to go up or down for if I spit up or down or left or right to see where a specific side is. And then I erase that from the data structure. And I just keep working my way down until I have nothing left. And from there, you basically have the number of sides, you have the perimeter, and you also get the area. All three things are found, and there's my answer to both parts. That's not a surprise. So let me show you what I did for part 2. For the second part here, let me pull up an Excel worksheet that kind of shows what I was doing here so you can kind of see the madness. And so for this part, I'm doing things using the corner method. And so basically, if you can figure out how many corners your object has, your polygon here, you can figure out the number of sides because they correlate, right? A triangle has 3 sides, which has 3 corners. A square or a rectangle has 4, and so forth and so on. And so the idea here is, I know this is what am I looking at here? Let's just presume that there basically is part of a garden, that's the black space, and let's just look at the three parts that kind of coincide and match up with the corner in the middle here, right? This corner point. And so there's 8 different ways this could go down because each one of these could either be on or off. And so what I'm doing here is, so that's why there's 8. This is, and think of this binarily, like 0, 0, 1, or 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's going to come into play here in a minute. But so what you're doing here is I'm just checking to my left first, is there a red square? And then I'm checking diagonally, is there a red square? And then I'm checking up, is there a red square? And you can see 0, 0, 0, 0, 0, 1, 0, 1, 0. And then from there, let's try to look at this and go, well, how many corners are there if this is the shape that I'm looking at for just this one specific instance? And so you look at this and you go, yeah, there's a corner here, so there's one corner. There's no corner here because this is a straight line. There's actually 2 here. I know you think that's not possible, but you can actually come around, right? So it is possible. And so in this case, there's a corner going this way and a corner going that way, so there's 2 corners. There's a corner here going this way. There's no corner because it's a flat piece. There's a corner going outward that way. There's one coming inward this way, and then there's nothing because this is in the middle. So my array comes out as 1, 0, 2, 1, 0, 1, 1, 0 if you take into account the way that you're going to test. Always go left, always go diagonal, and always go up. And so you will see that here in my code down here, or down here, there is this thing that I'm using. And so now you can see my code is greatly reduced. This is exactly the same as before. This is exactly the same as before. And so now this is the code that's different. And you can, now you can see that I get the same answers here, but I do not get, as I was saying before, I do not get the areas. Um, I get the areas. I just don't get the perimeters. I can get the number of sides, but this does not give me perimeters. So what am I doing? So so it's all worked down to be as efficient or as efficient in its inefficiency or whatever as possible. Let me see if I can move this over. Nope, I'm not allowed to. See if I can move that over. There we go. But basically, what I'm doing is exactly what I was saying, is that I'm looking at each individual square that's in my, that's in the garden. I'm checking all four corners. And so I have to check, and so the one thing that the little Excel worksheet doesn't show is that once you know what this corner, if you just rotate this thing 90 degrees and try again, well, now you'll get this corner. And if you do it another time, now you get this corner. And if you rotate a fourth time, now you'll figure out that corner as well. So basically, I can generate every one of the four corners for any object using this algorithm, as long as I keep in the understanding that I keep everything 90 degrees at a time. So like with these directions, I'm going to go, this is me testing left first, then up, then right, then down, and I can loop around again. So each one of these turns 90 degrees clockwise as I'm turning. And so when I'm coming down here, I'm saying, let me try this. Let me try the way we saw in the Excel worksheet, and then we'll turn it 90 degrees, then we'll turn it 90 degrees, we'll turn it 90 degrees, we'll generate all four of the corner points, and then basically from there we sum up all the corner points, and then we figure out, how many actual corners there are in an object. And so this is the fancy math that gets me there. The dir, the dirs here is up here, but this is just saying let's try to go left. Let's try to go up, diagonally up left, and let's go to the up. And then there's a bunch of math here just because I'm looping this 3 times over because I don't want to repeat the code. And just like before, like I was saying here, this is just testing. I'm testing, what am I testing first? I'm testing for, let me come back to this here. So because I'm going to add 4 to my number. I have an offset value, but if this is true, I'm going to add 4 to the number, which is 100. And if this is true here, this guy here, I'm going to add 2 to the number. And if this is true and this is located, I'm going to add 1. And that's how I get basically the offset value for which situation am I dealing with in this current in the current situation I'm at. And so the one other thing that I had to come up with to figure out was, well, that's great for individual units of the garden, but on the other hand too, we had to make sure that we don't have any duplicates. And so basically, if I find that a point is legit, I just have to make sure that I haven't tried it already from a previous garden position. And that's what this last stop here is basically say, get me the position of, and check to see if it's, if it's in, check to my left. Is that position where it is there a garden there? And if there is, have I checked it yet? And if the answer is no, well, then we're going to add that offset. And if we find that at any point along the way that, yes, that we've already checked that, well, then we don't need to double check. So this comes around and this will fall right out of the loop. And basically say, only in cases where we don't find points where we previously tested, that's where we'll use this fancy little array system here, this little list, and then we'll say, well, go off of that and get me the offset from what I got. So like this, and then get me, like in this case, get me offset 1. Like offset 1 will get me 0 coming back here, just one more time. This is saying I tried to go left, but there's nothing there. And I tried to go up and left, and I didn't get anything, and I went up here, and there was. So I know I'm using this case because I'm using offset 1. There's no corners there. And so minus all the duplications and going through this square by square by square, when you fall out of this thing finally, you get the area, which is the number of locations, times the number of corners that kind of comes out of this. And then we do the multiplication, we delete this from the map, and we start over again. And so, again, if you're the one who doesn't like what I did here, let me know how I could do it better, because I would love to know how to do this more efficiently if possible. This was my, like many of you, my first try doing this, and I actually succeeded, and I'm happy about that. So let's not shit on it, huh? Please, let's make it better. There's, many other people out there that don't have an answer to this problem, right? Looking at this here in the moment. Where's my day 12 here? In the moment, looking at the statistics, that is a lot of people who haven't solved it, right? So I want to know better. I've already solved it 2 ways. I want to know how to do a third way or a fourth way or a fifth way, because this is a fun problem. I want to know all the solutions to it. So thanks for watching this if you made it this far. Hope you guys have a great day. I hope day 13 gives us a little break because this was crazy. Well, thanks for sticking it out. Have a great day, everybody. See you later. Goodbye.